Okay, for question 2, we're still looking at the comparison between velocity and time, velocity and position over time, except this time we are given our opposite setup. We have we still have time as our x-axis, but we are given a velocity graph. And we are asked to switch it into, maybe a little bit better? No, this might be the last you see the pink marker. A time versus position graph. It is more complicated than our previous example, but not by much. So we are once again given time steps of 1 second between 0 and 4 seconds. And position and velocity that is fairly basic, but I'll go ahead and give it an extra line. Velocity that is varying between 0 and 3. Much nicer in that the x-axis is the same this time. For this, we have a diagonal line on our velocity graph. Now between 0 and 1, where we are increasing our velocity. We then have a constant velocity of 1 between 1 and 2, and between 2 and 3. And then we have a jump up to a velocity at 4 of 2 meters per second. So what I forgot to add is our time. We can still assume that we're more or less working in seconds. And our velocity, we are working in meters per second. Okay, then our position versus time graph. I believe that what I gave you is going to be time in seconds. And I gave you this much space to work on. So I have 0 through 4. I'm not spacing these out right for the length that I made this graph, but that is going to work out just fine anyways. Sure, good enough. So position is 1, 2, 3, 4, 5, and position is going to be in meters. Perfect. Okay, right to it. So we have a diagonal line here, which means that we need the area right in here is going to be our change. And for this position graph, we need to know where we're starting, and we are starting at 0. So the amount we're going to go up is going to be the area inside this triangle right here. So looking at the triangle, this is a bad triangle. We have a length of 1 here because we're going from 0 to 1. And we have a length of 1 here. Area of a triangle is going to be 1 times 1 and half of that, because it's half of the area of the full square. If this were a full square, it would have had an area of 1. So we have an area of 1/2. So that is how high our piece is going to go here. So we know that at time 1, our position is going to be at 1/2. Great. except we said in the last video that if it's a straight line on the position versus time graph, it's a flat line in the velocity versus time graph. So this is not going to be a straight line. It is going to be some form of curve. And how we're going to figure that out is, let's go ahead and take this and let's take our big triangle, much better, that was 1 by 1, and let's figure out what's happening at 1/2. So if I look at this, this is a straight line. So if this is 1/2, this is also going to be 1/2. Nice little square there. So what is my area at a time of 1/2? Well, 1/2 times 1/2 divided by 2 is going to be equal to 1/2 times 1/2 is a quarter, divided by 2 is going to be 1/8. So we're ending at 1/2, but the first half is only going up 1/8. If we continue to break this down, we're going to find that we've got a smaller area at the beginning, smaller amount added at the beginning, larger amount added at the end. So we end up with this nice little curve here. Notice how it's very small at the beginning and then it ramps up very quickly. So we will have curves like so. Don't worry about getting it exactly perfect. What is important here is that I'm starting with a very small change of position because it's a small velocity. I'm ending with a much larger change in position because towards the end it's a much larger velocity. So let's go ahead and add, this is at 1/2. Perfect. So this next piece between 1 and 2, well, it's got an area, let's do lines the opposite direction. Well, that's an area of 1 by 1, so I should be going up by 1. So this guy right here is going to be, I can't draw a straight line. Oh, it doesn't smudge, that's perfect. Is going to be right there, and that is going to happen to be at 1.5. And we can go back to our equation. If we don't trust this, we can say that x at point 2 is going to be equal to x at point 1 plus velocity between 1 and 2 times my time between 1 and 2. And for some reason, I decided to switch to 2-1 instead of 1-2. It's the time between those two. We'll worry about labeling a little bit later. So position at time 2, that's what we're trying to find. I know we already found it with the area, but let's do it as if we're solving for that. x2 is going to be equal to x1. Well, that was 1/2 plus our velocity between 1 and 2. Our velocity between 1 and 2 is a constant, which is why we can use this equation. We couldn't use it for that first little segment. So velocity between 1 and 2 is a velocity of 1. And our time between 1 and 2 is 2 seconds minus 1 second. There's a 1 second piece happening there. So 1/2 plus 1 times 2 minus 1, or 1 times 1. So this becomes 1.5, which is the position we put in there. Simple enough, hopefully. Might not be appreciating how long these videos are early, but hopefully I'm setting a precedent when things get a little bit more complicated. 2 and 3, well, it's doing exactly the same thing. So we're going to be doing exactly the same thing. It's going to go up by 1. So this is going to be at, I'm just going to put it right over here on the thing. We're at 2.5 here. Perfect. And then between 3 and 4, we'll write one more out. We'll say that x4 is going to be equal to x3 plus velocity between 3 and 4 times the time between 3 and 4. Perfect. x3 I know is 2.5. We're solving for x4. Our velocity between 3 and 4 is 2 meters per second, so 2. And time 3, 4 is going to be 4 seconds minus 3 seconds. That's 1 second. So I end up with 4.5. So now we'll just put it, hopefully that's acceptable for you. 4.5. So the slope of that line is a little bit larger. Now I could do it graphically still if I wanted to. I could say that I have this rectangle right here and I want its area. So I have a height of 2 and a width of 1. 2 times 1 is 2, so I'm increasing my position by 2. 2.5 plus 2 is 4.5. Done. Okay, let's get on to the little bit more interesting stuff.